This is Euclid Book 10, proposition number 66. Okay. And it says, a straight line commensurable in length with a binomial straight line is itself also binomial and in the same order. Okay. Or something like that. Anyway, let AB be a binomial. That's this line right here. And let CD be commensurable in length with AB. Okay? This line here is commensurable in length with this line up here. Okay? I say that CD is binomial and the same in the order with AB. For since AB is binomial, let it be divided into its terms at E. That's where we divided it. Let AE be the greater term. So this line here is bigger than this line here, obviously. Therefore, AE and EB are rational straight lines commensurable in square only. Okay? These two lines are rational, but they're only commensurable in square. This is by Euclid Book 10, proposition number 36. Let it be contrived that as AB is to CD, as this line here is to this line here, so is AE to CF. So is AE to CF. That's a ratio. Okay, and this is by Euclid Book 6, proposition number 12. Okay. Therefore, also the remainder EB, this is EB right here, is to the remainder FD, which is this right here, as AB, the whole line, is to CD. That is yet another ratio. In other words, as this is to this, so is this whole line is to this line. Okay. That's by Euclid Book 5, proposition number 19. But AB is commensurable in length with CD. Therefore, AE is also commensurable with CF. This is commensurable with this. Okay? And EB with FD. This is commensurable with this. That's by Euclid Book 10, proposition number 2. And AE and EB are rational. Okay? This and this, both of these are rational. Therefore, CF and FD are also rational. This is rational. And as AE is to CF, as this is to this, so is EB to FD. This is to this. Okay? This is by Euclid Book 5, proposition number 2. Therefore, alternately, as AE is to EB, as this is to this, so is CF to FD, and this is by Euclid Book 5, proposition number 16. But AE and EB, this one here and this one here, are commensurable in square only. Therefore, this line here and this line here are only commensurable in square. This is by Euclid Book 10, proposition number 2. And they are rational. This line is rational, so is this. Therefore, CD is a binomial. This whole length is a binomial. This is by Euclid Book 10, proposition number 36. I say next that it is in the same... Okay. I say next that it is the same in order with AB. For the square on AE, that's this one here, is greater than the square on EB, which is this one here. And you all know by now how we made all those squares. If you don't remember, we took the line AE, we made a square out of it, so all four sides of this square are AE. Same thing with EB. We took the length of EB, we made a square out of it, all four sides of EB are the length of EB, okay? For the square on AE is greater than the square on EB, either by the square on a straight line commensurable with AE, or by the square on a straight line incommensurable with it. If then the square on AE is greater than the square on EB by the square on a straight line commensurable with AE, the square on CF, we take this line, we make this square, will also be greater than the square on FD. We take this line, we make a square here. So this is actually going to be bigger than this, by the square on a straight line commensurable with CF. This is by Euclid Book 10, proposition number 14. And if AE is commensurable with a rational straight line set out, CF will also be commensurable with it. Okay? This is by Euclid Book 10, proposition number 12. And for this reason, each of the straight lines A, B, and CD, that's this one right here and this one right here. Both lines, this one here and this one here, are first binomial. That is, in the same order. This is by Euclid Book 10, second set of definitions, number 1. But if EB is commensurable with the rational straight line set out, FD is also commensurable with it. This is by Euclid Book 10, proposition number 12. Okay? So EB was the first line we referenced here, and FD was the second line we just referenced. And for this reason again, CD will be in the same order with AB. This will be in the same order with AB. For each of them will be a second binomial. This is by Euclid Book 10, second set of definitions, number 2. But if neither of the straight lines AE or EB, if these two lines here, now we're going to be referencing these two lines. If neither of the straight lines AE or EB is commensurable with the rational straight line set out, neither of the straight lines CF or FD will be commensurable with it. This is by Euclid Book 10, proposition number 13. And each of the straight lines AB and CD is a third binomial. Okay. So if neither one of these are commensurable with a rational straight line, then neither one of these, this line here or this line here, will be commensurable with a rational straight line. So that would make AB and CD a third binomial. But if the square on AE, right here, is greater than the square on EB, right here, by the square on a straight line incommensurable with AE, the square on CF, this one here, is also greater than the square on FD, which is this one here, by the square on a straight line incommensurable with CF. This is by Euclid Book 10, proposition number 14. And if AE is commensurable with the rational straight line set out, okay, let's say that AE is commensurable with some rational straight line that you set out, CF will also be commensurable with that same line. And each of the straight lines A, B, and CD will be a fourth binomial. Okay? So if this is commensurable with some extra line, and this is commensurable with that same extra line, then therefore this whole line here and this line here will be fourth binomial lines. This is by Euclid Book 10, definition number... Euclid Book 10, second set of definitions, number 4. But if EB is so commensurable, so is FD also. So now, if we have these two lines commensurable, and that would make each of the straight lines AB and CD a fifth binomial. Okay? Now, to move a little slower on this, what we're trying to say is, say there's some rational straight line out here in the universe. If these two lines are commensurable with that line, then AB and CD are going to be known as the fifth binomial. This is by Euclid Book 10, second set of definitions, number 5. But if neither of the straight lines AE or EB, if neither one of these are commensurable, then neither of the straight lines, this one or this one, will be commensurable. And they won't be commensurable with any rational straight line that we have floating around the universe. That means that if none of these lines are commensurable with a rational straight line floating out here, then what you have is a sixth binomial, and this is by Euclid Book 10, second set of definitions, number 6. Hence, a straight line commensurable in length with a binomial straight line is binomial and the same order. Oh boy. Let me read this to you again. Hence, a straight line commensurable in length with a binomial straight line is binomial and the same in order. Aren't you glad that proof is over with? I know I am. Alright, I will tell you more in a future video. Stay tuned.